The equation f of t equals negative 0.0197t squared plus 1.86t plus 9.90 models the percentage of Americans at age t years who say they do volunteer work. Suppose we want to estimate the percentage of 25-year-old Americans who say they volunteer. T is age in years. So for this problem, we're going to put in 25 to our function for t. This leaves us with negative 0.0197 times 25 squared plus 1.86 times 25 plus 9.90. This is an example of a problem that would be rather difficult to calculate the answer in your head, but luckily we've got our handy-dandy calculators to help us figure it out. Negative 0.0197 times 25 squared plus 1.86 times 25 plus 9.9. Here we get about 44.0875. So we can say 44.0875% of 25-year-old Americans say they volunteer. Our next question says, for what age do half of Americans say they volunteer? Half is the same thing as 50%. So we can set 50 equal to our entire function and solve it for t. 50 equals negative 0.0197t squared plus 1.86t plus 9.90. Well, this isn't one we're going to be able to solve by factoring, and completing the square with decimals like this would be a real pain. Let's use the quadratic formula. To use the quadratic formula, we need to have it equal to 0. So we subtract 50 from both sides, giving us 0 equals negative 0.0197t squared plus 1.86 t, and then 9.9 minus 50, we have minus 40.1. So let's set up our quadratic formula fraction here. We have our big fraction, negative parentheses, plus or minus square root under the square root of parentheses squared minus 4 times a parentheses, all that over 2 times a parentheses. Now for this equation, b is 1.86, a is negative 0.0197, and c is negative 40.1, like so. All right, so on the top, we have negative 1.86 plus or minus a square root. And because I know I'm going to be getting a decimal answer anyway, I'm going to go ahead and calculate everything under that square root. 1.86 squared minus 4 times negative 0.0197 times negative 40.1, we have 0.29972. All that divided by, and on the denominator, 2 times negative 0.0197, we have negative 0.0394. Okay. Next, when we calculate the value of that square root, oops, I typed something wrong into my calculator. 0.29972, take the square root. We get about 0.5475. So I calculate negative 1.86 plus 0.5475 divided by negative 0.0394, and we'll need to calculate the same thing with a minus in the middle of the top. Negative 1.86 minus 0.5475 over negative 0.0394. So calculating the first one, 1.86 plus 0.5475 divided by, oops, I typed something wrong in my calculator again. Negative 1.86 plus 0.5475 divided by negative 0.0394. Here I get for the first one about 33.3. For the next one, negative 1.86 minus 0.5475 divided by negative 0.0394, I get about 61.1. So there's two answers here. People who are a little bit older than 33 or people who are a little bit older than 61, about half of those would say that they volunteer. Now our last problem, part C, says for what age is the percentage who volunteer the greatest and what is that maximum percentage? This is going to be calculated using our vertex formula. When you're finding a maximum or minimum for a quadratic function, we need to know where the vertex is. B for this function is 1.86. A for this function is negative 0.0197. We have negative 1.86 on the top. In the denominator, we have negative 0.0394. If we calculate this, negative 1.86 divided by negative 0.0394, we get about 47.2. Now here, instead of going ahead and plugging that into our function, our answer needs to be an actual age here, I think. Let's go ahead and round this off to 47. You don't really talk about people who say they're 47.2 years old. We'll go ahead and round this off to a whole number of 47. So now we'll take this and plug that into our function, giving us negative 0.0197 times 47 squared plus 1.86 times 47 plus 9.90. All right, so let's see what this is. Negative 0.0197 times 47 squared plus 1.86 times 47 plus 9.9. Here we get about 53.8. So we can say that 47-year-olds have the highest percentage of people who say they volunteer at 53.8%.